I'd like to introduce now Nick Weaver, who's the Director of Software-Defined Infrastructure at Intel. Intel was one of our first customers. They're a partner of ours earlier this year. And Nick's going to tell you guys a little bit about a project that we're both very excited about, something called Snap. So Nick, welcome. Thanks.
I'm Nick Weaver. I work for Intel. That's us. Some of you may have heard of us. Wow, those lights are bright. Let me stand over here. We are going to be talking about, or I'm going to be talking about a project called Snap. But before I go into that, you may be asking yourself, why is Intel, a hardware company, up here talking about open source dashboarding, monitoring, alerting, that kind of stuff? Well, let me explain that. There's a couple things you may be familiar that we build, like chips, network cards, even like really cool stuff. Who's heard of like 3D XPoint? Something cool like persistent, 1,000 times faster than SSD storage, right? So we're really, really well known for hardware, and we're known for those kind of things. And we have, huge divisions of tens of thousands of people that think about chemicals and light rays and all kinds of stuff that me as a software guy has no idea what's going on. But we still have a unique problem in that with all this cool hardware and stuff we have eventually these customers over on the right-hand side who use these things. So if you look at reInvent this week, a lot of their announcements, a lot of that compute and hardware underneath the things and services they're building and announcing is actually built on a lot of our stuff. And a lot of customers have applications and services that eventually land on this kind of hardware. So our problem is, when we do these things, when we try to build this hardware to make those things better, applications, services, stacks, jobs, whatever the customer wants to call it, how does that apply? And how do you make those things more useful? And there's also an interesting fact that the patterns are changing. So before going back decades, and some of you may have been system ins long enough, you will know what I'm talking about, you kind of designed an application for one system. So you had a database, you looked up the white papers, you purchased the right hardware, and you installed it on that single system. Nowadays, we have all these new cool tools of automation, DevOps, configuration management, schedulers, containerizers, all kinds of technology and software and stacks and pieces that are all in between the hardware and the application. And automation is becoming so much more of a key component in driving that, because if you were running a couple hundred servers a decade ago, it was reasonable to have a few sysadmins on staff to keep them running. But when you start running tens of thousands or hundreds of thousands of instances or VMs or pieces of hardware, it gets really, really expensive to have 1,000 sysadmins all sitting around griping about it. And so we're looking for the ability to actually drive the new emerging stuff like the Kubernetes, like the OpenStacks, even the public cloud providers and their services and how they present hardware in ways that are valuable to the customers. And so one of the things you realize out of that is the amount of data that comes out of the platform, how valuable it is. If it cannot be observed, you don't know what to do with it, basically. And there's different levels of that. There's your classic reactive pattern where you're a user, you're using dashboarding to kind of figure out what's going on and troubleshoot or get indicators. And then there's toward the other end where the automation's emerging. We're seeing things like schedulers and in-memory resource representation, where computers are making decisions where humans normally did in the past, and the users define the policies and rules around it. So we were looking at this and saying, well, how in the world do we provide value here? And then what are the things we need to do on the hardware side, actually? Like, how should the hardware even be designed to fit into this space better? So the interesting thing about Intel is we have a pretty large market share in kind of back-end servers. And what do you do when you have a huge part of the market share? Like, how do you keep becoming valuable to customers? Well, you have to provide value. So the question we asked ourselves, this is about 3 years ago, was, well, how do we look at the data we provide? How do we make sure it's actually valuable? How do we even design our chips or our network cards? And how do we present it? And so out of that, we kind of looked at this pattern right here. And said, okay, so you're really looking at three kind of separate things. You've got data, right? So that could be hardware, that could be runtime, so like operating systems or things that are consuming the hardware and providing a new abstraction on top. It can be applications, it can be services, it can be all kinds of different levels. You have context, and context is things like where it's at, or these things are next to each other. So this server is having a health issue of some sort. Cool, that's not really useful to me because I don't know what's on that server. It could be in a closet somewhere and somebody forgot about it and it's been running for 8 years and nothing's on it. Or it could be my main critical database ETL backend server. The context is very important. And so this whole context problem was really interesting to us because, starting as an Intel and our chips and our telemetry, we're going, look at all this cool stuff. And the customers are saying, don't know what to do with all that cool stuff. And then the final thing was the places. And when I say places, I mean, if you take this data, you add context, and where you put it can vary by customer to a large degree. So if I'm exposing this stuff in a way to a user provides some value in Grafana so they can monitor and aggregate and get great visualization on what their data centers are doing, that's awesome. And then I go talk to Google, and they were writing schedulers that manage tons and tons and tons of stuff. They're saying, I need logical representation of this that I can create abstractions around and create rules and policies around for things like Kubernetes or internal tools. And they two similar things in one aspect, put the data somewhere, but the patterns are very, very different. And so we were looking at this and saying, well, how do I be very extensible against that? So out of that, we kind of came up with this idea and said, okay, well, there's kind of a pipeline here of those three separate things. And what if we were able to kind of build something to kind of expose extensibility in these three different areas in a way that we could drive value, where we could actually provide something valuable to the community? And then this pattern right here, this diagram right here, is how we ended up with Snap. So I'm going to tell you a little bit of this. So I haven't actually told the story, I think, in front of anybody before. Originally, Snap was 3 people. I was one of them, saying, we're going to go write something. And you're an Intel, a huge hardware company. We work in the data center division, so I don't get paid for writing software. I get paid if you keep buying servers. But I'm a software guy. Kind of weird, right? And so we said, let's just go build something, right? And let's go see what we have. We ended up looking at Intel's existing telemetry stuff, because Intel has a lot of divisions that do a lot of crazy stuff. And we found 17 different kind of telemetry tools that were internal, or ones where they had taken something external and they kind of like hacked against it. And we looked at them all and said, these are all kind of really focused on one narrow problem, right? Let's test laptops and find mean time between failure on individual components across thousands and thousands of laptops. That's awesome. Doesn't exactly apply to my problem. It can't copy and paste that. And so in the end, we said, okay, let's just go build something. Let's go build it in a language that we feel that no one at Intel has ever done before, Golang. We were the first ones to go do the Golang thing. Now it's popular, but. And then we went and built this thing, and then we open sourced it almost a year ago, December 3rd, 2015. We put it out there. And we were still a really small team back then. I think it was maybe like 6 or 7 people on it. And the response so far has been pretty huge for us. Not just externally with customers, including some pretty big ones, but even internally. We started having some fun, because if I go back to this problem right here, if you're over here on the left-hand side and you work for Intel, so you're a PhD in network jitter packets flowing over Ethernet something, right? You're an expert at that, and we have those, and they're amazing. And I say, cool, can you tell me exactly what network stuff they want to see? And they'll be able to recite it. Oh, yeah, you want to watch the jitter on this, it goes here, it does this, and if the Q-link goes over 5 and if the sun's out, you don't want to do this. And they know that stuff. They're awesome at it, right? And then I say, awesome, can you get that into a key value-based distributed storage backend over here so I can do poll queries against it for this scheduler that wants to update a local cache on its node? And they look at me like, I'm sorry, I don't understand any of the words you just said. Because at Intel, we have these experts that are vertical in certain areas, and they have no idea what the heck you guys and girls do in your jobs, right? Because they're very, very vertical. And so our goal was to go build a plugin model in Snap where I could have the experts in networking, the experts in storage, the experts in the chips and CPUs, in the persistent memory, in the FPGAs, and even higher up in that, our experts in our vertical spots that know automated driving, that know big data, have them provide value, but at the same time be able to sync that value, be able to sync that data, and support it in a way where it's super easy to consume by people that actually want to use it in their products, or in their solutions, or in their operations. So going back to Snap, I am not going to use this session to do a technical deep dive on Snap. I wrote a good chunk of it, and then over time I have been slowly pushed further and further away from it as my team took it over. So now I'm playing the strategic boss thing here. I'm going to tell you about why we did it and what we're going to do next. I'm going to announce the 1.0. Tomorrow there's a session by Joel and Matt from the team where they're going to do some really cool technical deep dive Q&A on some of the features here. So going forward, this last year, since it's the beta, we did some serious internal work. We said, okay, if we're going to, we released this thing and people are liking it, and we're getting a lot of popularity. In fact, right now, I think it's either the second or third most popular open source project Intel's ever done, which is not, we didn't think that would happen. It just kind of happened. And we said, all right, well, if people are going to run this in production, we're going to have to be better citizens. So we spent a year doing some stuff that was kind of non-obvious. We actually built, I hired a team, we actually built out a automated testing platform on Kubernetes that we run internally, which as snap commits goes in, we're able to scale out and actually test a whole bunch of stuff. One of the things we did, for example, is right now 10 of our plugins, and I'll get into plugins in a second, 10 of our plugins, every single snap commit, those 10 main plugins, which are really popular, every single one of them is tested against every single commit automatically. It scales out, loads every plugin, tests it, and we're going to expand that more and more and more. We also did a whole bunch of work on our build processes and just the kind of that bread and butter stuff you want to do that gives customers the ability to have confidence that this product is stable. And we did a massive amount of that this last year, hired a lot of great talent around testing, CI, automation, building to back Snap to make it more stable. And that was part of our push for 1.0. We also kind of kept a lot of our original features, which tomorrow's session will go into in more depth. But our tribe clustering, our dynamic plugin upgrades, the REST API, and our workflow model all remains, but we did a lot of work stabilizing those things and making them much more predictable. And finally, not finally, actually two more. We converted. We originally wrote an API model in the plugins that was based on Go binary. It was kind of restrictive, and we moved that to gRPC. Anybody familiar with gRPC? Any Go writers, Google fans? So we ported over to gRPC. We also said, well, if we're going to do that, we should also let the non-Golang friends out there write as well. And so we actually added support for C++, Python, and Go now have standard libraries for writing plugins in those languages. So you can actually write plugins for Snap in those. And then it's just a matter of bandwidth. And if anybody out here is big fans of Ruby or Erlang or any other languages and you'd like to write a library for writing plugins and Snap in that, ping me or one of the team and we'll show you how to do it. We're going to expand that even further. We also added other features like dynamic metrics, and this is a pretty huge one. And if you haven't used Snap yet, this might not be as obvious. But Snap has a really great job of exposing tons and tons and tons of different metrics very easily in a kind of runtime. So you can just dynamically load plugins, it'll inventory your system, and it'll just, so here's a whole massive amount of stuff you can go get. Well, the problem with the massive amount of stuff is, well, what if you're running containers? And how long does a container live? Anybody want to guess? Depends on the customer, but it can live like 4 seconds. So if you're trying to like grab some data off one of those things, you got to know its name, you got to go grab it at that point in time. That kind of sucks. Now, if you got a VM that runs for 3 years, that's not such a bad thing because they're named. But our original query syntax against our metrics was kind of static and inflexible. So we converted that to dynamic metric stack queries, which now allow you to do things like, hey, go get me any interfaces on any container and send them over here. And it's very flexible. You can do partial things. You can do some forms of regex against it. And, but you can do like dynamic queries directly against it. And a lot of the driver on this was a lot of our work on integrating Snap into Kubernetes and making sure we can support those things. By the way, bonus points if you know the things on the right there. Who got the joke? OK, thank you. I just want to appreciate somebody else is a fan of that show. Thanks. So the point of me being up here, actually, is to announce that Snap is officially, as of yesterday, we launched our 1.0. And that's our, I mean, all of us who actually do software for a living know that is literally just tagging something on Git. I mean, come on. It's just a string. But from an Intel standpoint, it's not. It's the fact that we have done the work. We have staffed the team. We are taking responsibility for the project to say, we feel like this is 1.0 ready. The original team was about 3 or 4. I say 3 because I don't like to count myself as part of the team. Now we're looking at like 25 people and very different skill sets, from super hardware deep knowledge to CI/CD experts to all kinds of different things. I don't know what that was. And so at this point, we're launching the Snap 1.0, and we're saying that we believe this thing's production ready. And we believe that at this point, it's stable enough to really start to explore for customers to run in production. We already have some customers who are running things in production already, who are in the audience, so I'll talk about it. But that's cool. You're going to hear more about that tomorrow from Joel. We also have work going on with Kubernetes and Open NFV. So we have, Intel joins a lot of things because we're kind of big. And we've done some pretty massive work with Kubernetes community. Who here runs Kubernetes, is familiar with Kubernetes? Who here attends SIGs? Anybody here attend SIGs? Okay, so They announced recently a big monitoring pipeline re-architecture. We were a huge part of helping with that and working with Google. And a part of that was to allow other things to participate better. Prometheus, Snap, any of them, to actually interact and integrate better with something like Kubernetes and provide value on top of it. The NFV stuff is getting really interesting too. So we write a lot of networking stack. We have a whole division, like a whole group that just does networking and at scale for big, big customers. Think about the biggest telecoms in the country, or any country, and we're usually in there. And Snap is becoming a pretty popular, interesting component for those kind of things. Also, there's the future of Snap. So we have 2017 coming in. We have a lot of cool things we're going to add. I mean, one of them is going to be streaming, because it's been a complete demand from our customers. So people that want to do logging, eventing through Snap, in addition to polling metrics, those kind of things. We'll also be able to do it in a way where you can do both at the same time. You can even do filtering on it. So you can be actually watching a log stream and collecting metrics and then deciding which metrics get sent based on what happened on the log stream. So there's some really powerful flexibility there, which I don't have time to go into. We're also talking about doing something called embedded plugins. So Snap right now, you load plugins dynamically, and you can load plugins, you can upgrade plugins, you can actually use Tribe. There's a demo that we couldn't quite get ready for today because Google wouldn't up my quota of a 10,000 node Tribe cluster of Snap nodes, where we can upgrade plugins in a 10,000 node cluster with one command. So you can literally just do rolling upgrades. You can just change where things point on a 10,000 node cluster with Snap with Tribe. We can only get it to 1,000 because then we had our quotas on GCP, and it takes a while to get it higher, so we didn't make it. Anyways, so the other point about this is there's a ton of other hardware telemetry that is right on the cusp of being exposed. So it took us about 3 or 4 months to get some of the teams who do some of the hardware stuff at Intel to understand what Snap was, to understand why they should do it. And then they've been working on some really cool stuff here. I can't demo it here, but I think Raj has seen it. But we have stuff like, can you imagine a Grafana being able to see like the lifespan of a hard SSD? So like literally this thing has 3 years left. It has 14 days left. Like that kind of level of stuff. And that's what we're looking to do. And we're looking to integrate all this stuff with Grafana. And so we do think Snap's kind of cool. We're a little proud right now, and you can only be proud for about 5 minutes, and then you realize you've got an insane amount of work to go do. But we didn't actually build Snap for most of what I just said, which seems silly. We actually built it because we wanted to do those other things. Remember I talked about the left side and the right side, hardware, and then all these customers' problems on the right? And some of those problems are really, really difficult. But some of those problems are actually solved at some places. If you look at some of Google's papers, anybody here read the Heracles paper? Anybody? One. Well, you work for us. I sent you that. So Google and a lot of these big companies, you go. I'll tell you, here's a homework assignment, which I don't know if you're supposed to do in a keynote, but here's a homework assignment. Go look up some of Google's papers on Heracles and Omega, and don't look at the papers like schedulers, SuperCloud, but look underneath the covers about some of the indicators in telemetry and monitoring, what they're using that for in making decisions. And so we're very interested in, if we could get telemetry to be consumable, if we could get some horsepower behind it, because remember, I don't get paid on software. If you use Snap, you don't actually help me get paid. I get paid if you actually get better at cloud. You get better at running stuff, and you end up buying more hardware. It's silly to say this, but if you choose to use Telegraph or Prometheus instead of Snap, that's cool. If the Telegraph or Prometheus people want any of the stuff I'm doing, I'll show them how to do it. Because the point is solving the problem, not necessarily if you use my software to do it. But what's next is that ability to bring and democratize out that really sophisticated ability to use telemetry for automation, for scheduling, for powerful technology inside your systems. And so on top of Snap, we're looking at these things. What if health was modeled for you? What if the entire server health rolled up into, it's perfectly healthy? There's some things wrong. Or you should take a look at this thing. And what if it was visualized easily? What if predicting failure became the norm rather than reacting to it? Anybody get that joke? Please tell me. Okay, thank you. Okay. I'm really nerding out on this slide deck, by the way. What if predicting failure became the norm rather than reacting to it? And that's a bold statement because most of us react. What if workload measurement was predictable? What if you could actually size and measure workloads in production or in test or in dev and be able to predictably know how they're going to run later? Better than that, what if colocation was predictable? What if telemetry was so predictable, so knowable, that you could know which workloads would actually run well next to each other? You could actually test and size it. What if schedulers like Kubernetes implicitly understood power, thermal, network queues, storage bottlenecks in a way where you can actually cross-schedule? And what if hardware is designed to expose telemetry that is relevant to the workloads today? So what if all that stuff ended up pushing back in the hardware roadmap in a way where you could actually do this stuff implicitly? So you just put something on an Intel server and instantly see how healthy it is without any kind of extra work. So the cool thing about this is the idea that there was an open source tool, that we focused this amount of effort on and actually delivered on top of. And that's the point of Snap, because most of what I just told you, the what if, is actual work we're doing right now, just not out yet, that's on top of Snap. So we actually built Snap to do that stuff and to extend it and to make it open source and effectively free in a way. And we got to buy our servers still, but Snap is not necessarily only an Intel thing either. It's an open source project. So, call to action, because I think I'm out of time, because Raj is getting close to me right now. So try Snap. Now, one thing I tell people, by the way, is I don't want any praise on Snap at all. I'd rather hear your critiques, your criticisms. We're way more interested in what you don't like than what you like about Snap. Thanks.